Hi, I'm Dr. De Bruin, and this is a quick walkthrough of how to answer an exam question from the equilibrium topic of AQA A Chemistry. A 50 cm³ sample of a solution of L is added to a 30 cm³ sample of a solution of M. The mixture is allowed to reach equilibrium. The amounts in the equilibrium mixture are 0.0245 moles of K, 0.0375 moles of L, 0.0105 moles of M, and 0.0315 moles of N. Calculate the amount in moles of K before the reaction with L. Use your answer to calculate the concentration in moles per decimetre cubed of K in the initial 50 cm³ sample. So there's quite a bit of information in here that I don't actually need because this would be the first part of a longer question. But in order for me to work out the initial moles of something, I'm going to need to draw an ice table. So this is a little table that's going to include the initial moles, the change in moles, and the equilibrium moles for each of the species involved in my reaction. So I can start off by filling in the bottom row of my table because all of that information is given in the question. Now in this question there's no mention of any M or N in the reaction starting mixture, and also if I have a little look, they're in a 1:3 ratio and the equilibrium moles of those are also in a 1:3 ratio. So that gives me a very good indication that there wasn't any M or any N in the reaction mixture to start with, and therefore I can fill in my initial moles there as 0. So I can then go on and say that the change in M is an addition of 0.0105. And I don't actually need to fill it in because I've got the information from M, but for the sake of completeness I could also say that N has increased by plus 0.0315. Now I know that I can use the molar quantities in the simple equation to say what the ratio between all of the reactants and products are. So for every 1 mole of M I make, I've lost 1 mole of L and 2 moles of K. Now for this question I don't actually need to worry about L at all, but for the sake of completeness I can say that that's decreasing by 0.0105, and then I can say that K has decreased by twice that much because the coefficient in front of K is 2. And then I can go on and use those numbers to calculate the initial moles. So as we said, we don't really need L, but it's nice to fill it in for the sake of completeness. And so K, if we add that on, we're starting with 0.0455 moles. But the question doesn't finish there because it didn't just ask me how many moles there were, it also asked me to calculate a concentration. So since it's the initial concentration, I'm using that initial volume. I'm not worrying about adding volumes together, that would come later. So I'm going to do concentration is moles divided by volume, but that volume of course needs to be in decimetres cubed. So my 50 here needs to be divided by 1000 to convert it. So I can then do my initial moles of 0.0455 divided by the volume of 0.05, and that's going to give me an answer of 0.910 moles per decimetre cubed. And I've given my answer to 3 significant figures because all of the numbers given in the question are also to 3 significant figures. Thank you very much for watching, and I hope you found that a useful exercise to go through. If you did find the video useful, then don't forget to like, subscribe, comment and share the channel, and I'll be back soon with more A-level chemistry exam walkthroughs.